Have you ever looked up at the night sky and wondered, where do all these stars come from? How are they born? And what happens when they die? In this video, we'll uncover the entire life cycle of stars, from their birth in massive cosmic nurseries to their dramatic deaths as supernovas or black holes. And trust me, what happens at the end of a star's life will blow your mind. So make sure to watch till the end, because by the time this video is over, you'll never look at the night sky the same way again. Welcome to Stellar Studies, your gateway to the wonders of the universe. Let's start this stellar adventure. Chapter 1. The Birth of a Star. Deep in the cold, dark reaches of space, something extraordinary is happening. Within these massive clouds of gas and dust, the seeds of stars are quietly forming. These cosmic nurseries, called nebulae, are where every star's journey begins. But how does a lifeless cloud of gas transform into a brilliant, burning star? It all starts with gravity, one of the most powerful forces in the universe. Over time, small regions within the nebula begin to collapse under their own gravity. As more and more material falls inward, the core grows denser and hotter. This is the birth of a protostar, a newborn star still wrapped in its cocoon of gas and dust. But at this stage, it's not yet a true star. Something crucial needs to happen first: nuclear fusion. As the protostar contracts, temperatures in its core skyrocket. When it reaches a scorching 10 million degrees Kelvin, a miracle of physics occurs. Hydrogen atoms begin fusing into helium, unleashing an enormous amount of energy. This is the moment a star is truly born. Now the battle between gravity, pulling inward, and fusion pushing outward creates a delicate balance. This newborn star will now enter the longest phase of its life, the main sequence, where it will shine for millions or even billions of years. Our very own sun went through this exact process about 4.6 billion years ago, and today it still burns bright in the sky, keeping our planet alive. But what happens once a star settles into this stable phase? And how does its mass determine its fate? Let's find out. Chapter 2. The Main Sequence Phase. A star's prime. At this moment, billions of stars across the universe are in their longest and most stable phase of life, the main sequence phase. It's the prime of a star's existence, where it shines steadily, burning through its vast reserves of hydrogen fuel. But not all main sequence stars are the same. Their size and color reveal how hot they burn and how long they will live. Let's break it down. Small stars, like red dwarfs, are cool, dim, and burn their fuel slowly. They can live for trillions of years, outlasting most of the universe itself. Medium stars, like our sun, burn steadily for billions of years before evolving into something new. Massive stars, however, are different. They burn hot and fast, shining blue-white and consuming their fuel millions of times faster than smaller stars. While they may be spectacular to look at, they live only a few million years, an instant in cosmic time. Right now, our sun is in the middle of its main sequence life, having already burned for 4.6 billion years. It has enough fuel left to shine for another 5 billion years before it moves on to its next stage. But what happens when a star runs out of fuel? Does it simply fade away, or does something far more dramatic take place? Chapter 3. The Fate of Low and Medium Mass Stars, like our sun. Every star, no matter how bright, eventually runs out of fuel. And for stars like our sun, the end is not as violent as a supernova, but it is still spectacular. After billions of years of burning hydrogen into helium, the core of the star begins to shrink under its own gravity. With less outward pressure from fusion, the delicate balance that kept the star stable for so long is now broken. With the core contracting, the outer layers expand outward, turning the star into a red giant, an enormous, swollen version of itself. If you think our sun is big now, imagine it 100 times larger, stretching all the way to Earth's orbit. In this phase, the sun's heat will boil away Earth's oceans, leaving our planet a scorched wasteland. But this phase is short-lived. Eventually, the star can no longer sustain fusion. It sheds its outer layers into space, creating something truly beautiful, a planetary nebula. Despite the name, planetary nebulae have nothing to do with planets. They are the dying breaths of medium-sized stars, leaving behind clouds of gas that drift through space for thousands of years, seeding the universe with elements for new stars and planets to form. At the center of this nebula lies what remains of the star, the white dwarf. This tiny Earth-sized core is unimaginably dense. Just a teaspoon of its material would weigh tons here on Earth. With no more fuel to burn, the white dwarf will slowly cool down over billions of years, eventually becoming a cold, dark black dwarf, a silent remnant of a once glorious star. This is the fate that awaits our Sun. No explosion, no supernova, just a slow, graceful fade into the cosmos. Chapter 4. The Fate of Massive Stars, Supernovas, and Black Holes. While stars like our Sun fade away peacefully, massive stars, those at least 8 times bigger, meet a far more dramatic and violent end. These cosmic titans shine brighter, burn hotter, and live shorter lives. And when their time is up, the universe witnesses one of the most cataclysmic events known, a supernova. Unlike smaller stars, these giants don't stop at burning hydrogen. They forge heavier and heavier elements, carbon, oxygen, neon, silicon, until they reach the final, deadly element, iron. And this is where everything falls apart. Unlike other elements, iron does not produce energy when fused. It only absorbs it. With no energy left to fight against gravity, the star's core collapses in an instant. Imagine an object millions of times heavier than Earth, shrinking from the size of a city to just a few kilometers wide, in less than a second. This collapse triggers an unimaginable explosion, a supernova. For a brief moment, this explosion outshines entire galaxies. The blast scatters newly created elements, gold, uranium, and even the carbon in our bodies, across the cosmos. Every planet, every asteroid, even you, are made from the remnants of ancient supernovas. But what remains of the core depends on just how massive the star was. If the core is between 1.4 and 3 times the mass of our Sun, it crushes itself into an ultra-dense, fast-spinning neutron star, a star so compact that a single teaspoon of its material would weigh 1 billion tons. Some neutron stars become pulsars, sending out beams of energy that sweep across space like cosmic lighthouses. But if the original star was even bigger, the collapse doesn't stop. Gravity pulls everything inward beyond the point of no return. The core vanishes into a black hole where not even light can escape, a place where time slows, space bends, and the laws of physics break down. This is the most mysterious and powerful object in the universe, the final fate of the largest stars. But no matter how a star meets its end, its death is never the final chapter, because from the ashes of old stars, new stars are born. Conclusion. The story of a star is not just the story of light and fire, it is the story of the universe itself. Every star, from the smallest red dwarf to the most massive supergiant, follows a path written by the laws of physics. But their deaths are not the end. They are the beginning of something new. From the ashes of old stars, new ones ignite, continuing the endless cycle of creation and destruction. Our Sun, our planet, and everything we know exists because of this beautiful cosmic dance. And right now, as you watch this video, countless stars across the universe are being born, while others are taking their final breath. So the next time you look up at the night sky, remember, you are connected to those distant stars in ways you never imagined. Their story is our story. We are, quite literally, made of stardust. Thank you for watching Stellar Studies, where we explore the wonders of the universe. If you enjoyed this journey, don't forget to like, subscribe, and hit the bell icon so you never miss an adventure beyond the stars. Until next time, keep looking up. This is Stellar Studies signing off. See you in the next video.